Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the first chapter of 9th standard mathematics, that was on number systems. So in this particular video, I'll be teaching the examples which were left out before exercise 1.3 and the exercise 1.3 questions. So now coming to the next example in this particular chapter, we'll start looking into example 6. So in example 6, what they have asked is, so they have given a particular number 3.142678. So now you have to express this as a rational number. So how to express this as rational number? So just count how many digits are there after decimal point. So that many zeros you can put after 1. So that means, for example, if 6 digits are there, then take 1 followed by 6 zeros. So that is 10 lakhs and multiply that with this particular number. And always remember, when you multiply a particular number to the numerator for this particular number, then denominator also the same number should be multiplied. For example, here in the denominator 1 will be there. So always remember, if you are multiplying a particular number to numerator, then the same number should be multiplied to denominator also, so that this particular value will not be altered. The value remains the same. So that's why when you multiply this 10 lakh, that is 1 followed by 6 zeros, to this particular number, you will get 3142678, and in the denominator you will get 1 followed by 6 zeros. So now you can see this is also an integer and this is also an integer, and also here denominator is not equal to 0. So this is in the p by q form, where p and q belongs to integers and q is not equal to 0. So now by doing this, you can express this in p by q form, where this particular number is a rational number. Next we will see the example 7. So in example 7, you have a recurring number after the decimal point, that is 0.33333. It goes on like that. So this is nothing but 0.3, and if you put a bar on this particular 3, means that particular digit is recurring in after that particular decimal point. So that means here if I put bar on this particular 3, then that means this 3 is recurring. So now we have this 0.33333 value. So you have to express this particular number as a rational number. So in order to do that, just see how many numbers after decimal point is recurring. So here one particular number is repeating, that is 3. So here only one number is repeating after decimal point, that is 3. So that's why you can now multiply this 0.333 with 10. So always remember, if one number is repeating after decimal point, then you have to take 10, that is 10 followed by 1. So similarly, if 2 digits are recurring after decimal point, then you have to take 2 zeros after 1, that is 100. So like that you can do. So now I will multiply 0.33333 with 10. So before doing that, I'll consider this 0.33333 as x, and I'll multiply x with 10. If you call this as equation 1, then multiply 10 on both sides to equation 1. So when you do this, you will get 10x in LHS and 3.33333. It goes on like this in RHS. So now you have the equation 10x is equal to 3.3333, and infinitely it goes on like this. So now in the place of writing 3.33333, I can write this as 3 plus 0.33333, because if I do 3 plus 0.33333, you will get 3.333. It goes on like that. So now I have separated this 3 and 0.333. So I know this particular number we have called as x. So you can straight away write 3 plus x. So in LHS you have 10x. Now you can bring this plus x to LHS, so it will become minus x. So 10x minus x is equal to 3. So you got 9x is equal to 3. So now we are getting 9x is equal to 3. So when you bring this 9 to RHS, it will go to denominator. So x will become, x is equal to 3 by 9. So 3 by 9 means it is 1 by 3. So now you have expressed 0.33333 as 1 by 3, which is x. So this 1 by 3, you can see 1 is also an integer, 3 is also an integer, and denominator is not equal to 0. So this is a rational number. So now coming to example 8, here also it is similar to example 7, but here they have given 1.27, 1.272727, and it goes on like this. So here two digits are recurring after this decimal point. So in the place of writing 272727, I can just put bar including both 2 and 7. So that means this both 2 and 7 are recurring. So here two numbers are recurring after decimal point. So here you can multiply this with 1 followed by 2 zeros. So that is 100. So when you multiply 100 to this, you will get, or else first you take this as x. So x is equal to 1.272727, and goes on like this. So here you can multiply 100 on both sides. So when you multiply 100 on both sides, you will get 100x is equal to 127.2727, like this it goes on. So now you have got 100x is equal to 272727, like this it goes on. So now in the place of writing 127.272727, I'll write this as 126 plus 1.2727, and it goes on like this. So this 1.272727, we have considered this as x, so you can just substitute x there. So 126 plus x, 100x is there in LHS. So if you bring this plus x to LHS, it becomes minus x. So 100x minus x is 99x, which is equal to 126. So x is equal to 126 by 99. Here you can clearly see 126 is also an integer, 99 is also an integer, and denominator is not equal to 0. Or you can further simplify this and keep 14 by 11 also. So 14 by 11 is also a rational number. Coming to the next example, that is example 9. So in example 9, you can clearly see they have given a particular number, that is 0.2353535, and it goes on like this. So that is nothing but 0.235, and this recurring is happening only for this 35. That means 2 is not included in this. So 0.2353535, it goes on like that. So now you have to convert this to a rational number. So in order to convert this to a rational number, so you can just take 0.2353535 as x, and you can multiply 100. So because here also two digits are recurring after decimal point, so that means at the end of the number you have two digits recurring. After decimal point to the end, you have two digits recurring. So that means you have to multiply this with 100, that is 2 zeros followed by 1. So multiply 100 on both sides to this particular equation. So it will become 100x. So when you multiply 100 with 0.2353535, it will become 23.535, and it goes on like this. So now you have 100x is equal to 23.5353535, it goes on like this. So now you can write this as 23.3 plus 0.23535, and it goes on like this. So here you can clearly see we are again getting the x value. So 100x. So the simplest way is, so just subtract this x value with this 23.5353535. So you'll get this 23.3, and 23.3 plus 0.2353535, you can just put like that. So that means here you can just subtract 23.53535. So it goes on like this. This you can subtract with x. So that is 0.23535535. So when you do that, you will get 23.3. So this value only I have kept here, plus x I have done. So that means it is easy to split this particular number where we can get the x value. So now we have got this. So 23.3 plus x. So minus x, it will become minus x when this plus x is brought to LHS. So 100x minus x is 99x is equal to 23.3. So now you can bring this 99 to RHS, it will go to the denominator. So x is equal to 23.3 divided by 99. So now we are getting x is equal to 23.3 divided by 99. So here decimal point is there. I have to remove this decimal point. So I'll multiply 10 to both numerator and denominator, because when I multiply 10 to both numerator and denominator, this 10 and 10, if it gets cancelled with each other, then again you will get the same value, that is 23.3 divided by 99. So that's why when you multiply 10 to numerator, then you have to multiply 10 to denominator as well, so that equation is, or the value is not altered. So x is equal to, when you multiply with 10, it will become 233 divided by 910. So here you can see 233 and 910 both are integers, and also denominator is not equal to 0. So this is rational number. So now we will look into example 10. So in example 10, you have to find irrational numbers between 1 by 7 and 2 by 7. Write any one irrational number in between 1 by 7 and 2 by 7. So now in order to do that, you can just take the value of 1 by 7. So what is the value of 1 by 7? Value of 1 by 7 is 142857. So again this particular number is recurring. So that means here also recurring number is coming. So that means this 1 by 7 is a rational number. So when you take the value for 2 by 7, here also you are getting 0.285714. Here also this particular number is recurring. So that means even 2 by 7 is a rational number. But you have to find irrational number between 1 by 7 and 2 by 7. So that means here the number should be greater than 0.142857 and it should be less than 0.285714. So in order to do that, you can just start a particular irrational number with 0.15, because the moment when you take 0.15, this is greater than 0.14. So here we have 0.142857. Don't worry about this. Just take this particular number. Just do the increment of this particular number, that is 5. So now you got like the number which is greater than 0.14, and if you compare this with 0.285714, this particular number is less than 0.285714, because here you have just 0.1 and here you have 0.2. So that means this particular 0.15 is less than 0.285714. So this is recurring. Here also it is 142857. So this is also recurring. So you have got a number between 0.142857 and 0.285714. But this is not an irrational number, because here after a certain value you are reaching 0. So that means if nothing is there, means after a particular number, after decimal point, then that means the number is, the value is terminating. So that means 1.15 is there, means that is nothing but 0.150. So that means the value is ending with 0 after decimal point. So this is not a irrational number. So in order to make this irrational number, you can just go on putting random numbers. So 1, 5, 3, 6, 5, 7, 2, 1, 3, and it goes on like this. So random numbers you can just go on writing, and you should not end this. You should put these dots. So these dots indicate that this value doesn't terminate here. It keeps on going. And there is no recurring numbers as well. So there is no recurring pattern coming after decimal point anywhere. So that means this particular number is an irrational number, because I have taken 1, 5. So that means this particular number is in between 0.142857 and 0.285714. And this particular number has no recurring numbers after decimal point, and it is not ending also. It is not ending, it is just keep on going. So here you can see 1 5 is there. So after 1 5 it is ending. But here I am writing 0.153657213. So that means it is not ending, and I am putting dots over here. So these dots indicate that there is this particular value has not ended and still it is moving on. So that means this particular number is an irrational number and it is in between these two values. So this is all there in this particular video. Here I have explained the examples which were discussed in this particular textbook. In my next video I will be explaining exercise 1.3. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.